Hey guys, my name is That Quiet Kid, and today we're going to do a room called ret2libc, which is a room which teaches us basic return-oriented programming, exploitation of binaries, and an ASLR bypass. So let's click complete on task one. I know the essentials of binary exploitation and want to continue. So let's move on to task two and start this machine. So welcome to the room, red to I guess it's return to libc. It is telling us to just start the machine or use this attack box, which we'll do later. Return oriented programming, the basics of return oriented programming is changing. So basically, it chains together, which means combining together small chunks of code which are present in the binary in order to manipulate in a way so that we can use to get reading a file or getting a shell. This return to libc attack is ROP with a small difference. The difference is that these small chunks of code which we will be using are in the dynamically linked C library called libc. So dynamically linked means it is changing linked C library called libc. Why do we use libc? Well, it's already linked to our binary, and libc has some of the functions that are interesting. It's one of the functions that are useful to us is called system, which lets us execute anything past it. Now what if I tell you in libc there is also string value that looks like slash bin slash sh, which is bin slash shell. I think you know where this is going. I'm trying to get root here from this binary. All we have to do is create a ROP chain, small chunks of code chain together, and that passes the slash bin slash sh string as an argument to the system function and then calls this function. So that's it. You will know how the read to libc attack works. If you are done reading your machine, you can use the SSH credentials to connect. So start the machine. We have started the machine. It is written here. It will take up to 3 minutes to boot. And what is the name of the function that is essential for return to libc attack? I guess it was system. Yes, it is correct. So let's move on to task 3. Let's first connect to the SSH. Let's see, can we ping this IP yet? I have already connected to the Tryhackme VPN. The command is simple: open VPN and then your VPN configuration file. So let's ping this machine. Can we reach it? Okay, it's a Linux machine. Time to live is 63. If it is less than 64, then it means it's a Linux machine, and if it is around 128 or 131, then it's a Windows machine. So yes, we can reach it. So SSH, the name was Andy at the rate IP, and what was the password? It was ret2libc. Yes, click yes and type in the password, which was ret2libc exclamation. Okay, so now we have completed task 2. So let's move on to task 3, which is throughout the room I will be using listed tools that will make the process of binary exploitation and reverse engineering much easier. I will provide you links to the official documentation of every tool if you want to pawn tools. It is pre-installed on Kali Linux, so we don't need to GDB. It is also pre-installed on Kali Linux. So Ghidra is the one we have to install. If you want, they have provided the link from which you can install. I understand which tools are used throughout the room, and I'm ready to continue. So let's click on complete and move on to task 4. So okay, after connecting to the boss, go to the Andy's home directory. There you will find a binary called exploit me. So let's see. Let's click ls. Yes, we have find it. Let's run ls/la to see the permissions on specifying the file as well. So let's see in one line. So as you can see that this is read permission, second is write permission, this, and there is s, which means suid bit set. So basically this suid bit set is a kind of a way through which we can exploit to escalate our privileges. So there you can see there's a security bit in place, which means we could maybe escalate privileges. So let's see the architecture by running the file command and the file name, and we can see that this is lf 64-bit LSB executable, which is x86-64 version, and SYSC dynamically linked lib64 LD Linux, this, and it is not stripped. So let's move on. It is telling us, if you go to this page, you will find the information uh, about calling conventions, which is architecture is this, name is this, operating systems, compiler, register, order for parameters, arguments. So these are the registers. So basically then in this it's kind of a reverse engineering is related to microprocessor. In this way, these are the register. You cannot directly move data from one place to other. First you have to move data into a register, and then that register will place data somewhere else. So running the binary, so let's run this binary dot slash. It is executable as well. The x you see in this permission means executable. So let's run this, and it is asking for our name. So my name is that quiet kid. Okay, so it is telling me your name is that quiet kid. So let's see what we have. The first thing we should hit our head when seeing this binary like this is if it is vulnerable to buffer overflows. So let's use Python 3 to generate some string. We'll use print a cross 30 times. I think this is the correct syntax. Yes, it is. Let me copy it. Let's exit out of this Python and let's run this exploit underscore me and see if it is vulnerable to buffer overflow or not. So click enter, and it has stopped. And we see segmentation fault code, which means it is vulnerable to buffer overflows. Okay, so the next step is finding the offset. So let's use GDB. If it was a Windows binary, I could have used Metasploit's, I guess it was Metasploit's pattern create MSF's pattern create, but it's a Linux. So let's use GDB and the file. Okay, it's exploit underscore me. Okay, next we have to do is pattern create and simply run it by using R. Okay, okay, now it's working. So what do I have to do? It was pattern create, and it has created the pattern. Let's copy it out. We can simply run this binary by using R. Click enter. This is running, and it will ask us for our name, and we'll paste this pattern that we have created. Okay, why isn't it asking for? Okay, type your name. It has asked for my name. I will click enter, and now it has stopped. And let's see what are we looking at here. If you followed me step by step, you could see the offset in the GDB by yourself, and keep in mind, because we will need it for crafting our payload. Pattern create search RSP. Note, if you are working with a 32-bit binary, we are working with a 64-bit binary here, which we learned earlier. As you can see that when we ran this uh, file command, you can see that this is a 64-bit LSB executable. So now we are looking at RSP. So the RSP address is this. Let's copy it out, because this we will need. RSP is the one which is, I guess, stack pointer. Let me see, where am I? Okay, I am here. RSP, I guess it is return stack pointer, and RIP is index pointer, I guess. I'm not sure about RIP. If you're working with 32, then we're looking for IP, but we're using 64-bit here, so we'll be looking at RSP. And what are we looking at? Pattern search. Yes, pattern search. It will tell us the offset. At the offset is actually the point at which this binary breaks. Pattern offset. It was pattern offset. Pattern search. Pattern search. place the RSP, and it is found at 18. So 18 is the point at which this binary breaks. Buffer overflow works. So we can use pawn tools to check for any protections on this binary. And the main thing we should learn from this is the binary has, okay, let's exit out of this. Okay, exit doesn't work. I guess quit works then. Okay, quit works. So check sec the file name, which was exploit underscore me, and we see, okay, it is taking a long time. So what we have here, the binary has partial rel arrow, which means the global offset table is read and writable. Stack canary isn't found, which means that there is, if there is any buffer overflow, we can simply abuse it. Annex is enabled, which means we cannot execute custom shell code from the stack, and it is also the main reason we are using ret2libc attack. PIE is disabled, which means our binary will always start at the address this 4 lakh, won't be affected by ASLR. Okay, so the output is arch. It's arch 64 liter, and redlock is partial redlock. Stack is no, canary found, annex enabled, no PIE. Okay, so what are the permissions of the exploit me binary? We already know the permissions when we run ls dash la. So let's copy it and place it here. So what are the permissions? So it is asking for something one root. Okay, so it's one root, the whole permission. You can see it right here. Okay, so at what address will exploit me binary start? At which address? So it will at 0x4 lakh, I guess. Yes, it was this. You can see it right here. What is the buffer overflow offset that we find in GDB? It was 18. Click enter, and ASLR and GOT. So what is ASLR? Address space bound randomization. So it is a technique involved in preventing exploitation of memory by randomly arranging the address space positions of key, areas of processes, and the positions of these stack, heap, and libraries. First of all, we can check if SLR is turned on our VM with command this. Copy it. Let's place it here. Yes, it says 2. So what does this mean? So according to this, 2 means fully randomization, full randomization. This means the ASLR is turned on. But we learned already that ASLR, there isn't, this binary isn't affected by ASLR because there is no PIA protection, right? Yes, you're right, it's not affected, but the other thing is being affected is the libc, which is dynamically linked to our binary, and we can see that at the end we can see it is key arranging the address space positions of key data areas of possesses and positions of stack, heap, and library. So it deals with library, and we have a library that we are attacking, which is dynamically linked. We have a function that is dynamically linked to our binary. So but because of SLR we cannot call this as a function because we don't know the address of this function in libc. Okay, so we don't need the we don't have the address. Global offset table is the section inside a program that holds the addresses of dynamically linked function. Most programs don't include every function they use to reduce binary size. Instead, common functions like those are linked into the program. So uh, they are loaded into memory when the program is launched. However, functions aren't mapped to the lecture code until they are first called. So, okay, saved in the section program got. After the function are called for the first time, their real address are saved in the section of the program called got.plt. So the bypass. So how can we bypass? Okay, we need some function that can print value and take a pointer as an argument. The perfect functions for this are puts and printf in, and so we need to do is call puts as an argument, pass a pointer to the any function that's inside god.plt. For example, if we call puts and as an argument we pass the address of the stat buffer set buff function inside of .got.plt section, then we should have leave the real address of this function inside libc, and we have When we have a leak, we can calculate the base address of the libc. Libc base address equals to start of the C library in memory. What is the name of the section of the binary that is imported for our leak? It was got.plt. If you don't understand this on the first read, don't worry, take your time, read it through slowly. And when we have the base address, every time the binary is being run, the address is the same as it would have been when ASLR was turned off, and from that we can calculate offsets for every function inside of libc. Or we can simply rebase our libc, which I will talk about in the next talk. So let's use Ghidra now. And now is the point we will use this attached VM. So let's start our attack box. So transferring the binary, we can transfer it to our own to our own Kali machine. That is, I'm using Kali Linux here. I can also transfer it by simply, starting a python 3 dash m http dot server. Okay, it has started server on port 8000, and I can simply wget http the machine's ip slash the this exploit underscore me. It's not ip, it's actually we have to place the correct ip, but the point is we can encounter some problems. You can use ldd exploit me to do that. If you still have problems, I recommend using Kali Linux or the Tryhackme attack box to review this binary in Ghidra. Okay, so let's transfer it. So let's see, we will use attack box, but let's try to use it with Ghidra as well to see if we run into some problems or not. This slash, I guess port was 8000 that we are using, and the name is exploit underscore me. Yes, yes, we have transferred it. So the command was ldd exploit me, and let's run it here as well, which was ldd exploit me. And we see this x64 libs.s.o, and let's run it here. Okay, what are we looking at? Okay, so by transferring, before transferring, make sure that your machine uses the same libc as the attached VM, otherwise you can encounter some problems. So this has also started our attack box, which is the attached browser VM. It's also running now, but it's not showing, failed to connect to the server. Let me refresh it. I guess where is Ghidra? Let's locate Ghidra. I guess it's run. Where is it? Okay, so opt, this is the location. So let's run this. I have Ghidra. Okay, it doesn't run. It didn't run. It has happened. So let me go to this location. Okay, it has started. So Ghidra started in our VM as well. So we will use this and this both at the same time, I guess. So let's go to terminal. Let's locate Ghidra. Okay, yes, close it. Okay, let's create a new project next, and the location is ret2libc project directory. Let's change it to home slash kali slash it's mvf slash what's my name, Tryhackme slash, and the name of the directory is ret2. Let's see. Okay, the project name be hello. I know hello. Okay, so let's import our file here. Okay, so we'll have to go some system root inside home, inside Kali, and we will have to go inside mfv, and inside this there is a Tryhackme folder and ret2libc, and our file is this. So let's select file to import, and it is importing. I'm importing in my own Kali machine as well to see if we run into any situations or not, any errors or not, and we will run it here as well. Okay, so I'm looking for Gidra. So let's use locate. Okay, locate Gidra here. Where is it? Okay, I guess there is a folder called tools. So I guess it will be inside this. Okay, what do I see? Do I see something? Do I see something? Additional tools. Yes, I see Gidra here. So I guess this Gidra run is the file we have to run. Let's run it. And okay, select file to import, but I already imported it. So let's run it. Yes, Gidra is working right now. And Gidra is also working right here as well. Now we don't need any team tip. So let's click on new project. We'll name this hello as well. Let's name it hello. It's very simple. And import file. We can click on import file. Okay, where am I? Okay, I guess we are in. Okay, you'll analyze it. Okay, where am I? It's root, desktop, tools, my computer. Inside root folder, where is the root folder? It is here. And tools, scripts, room, postman picture, instructions, hello, downloads. Where was I? Wait, let before importing I will have to see where this file is located. So let's open terminal, pwd to see print working directory, where inside root and ls. Okay, so it's inside root. Gidra is working, I guess. Where is Gidra? Yes, Gidra, hello, working. Okay, let's go to file, import file, all files, loadable files, container files. Yes, it is all files, but why I am not seeing this? Where is it? It has it, no? So it doesn't have. Okay, okay, we can do this. Where am I? Where am I? Yes, I am here. Let's start our Python server here as well. Go to here. It's wget http $, this, and what was the IP? What is the IP? It's okay. Where am I looking at? Let's go up, and the IP is 10.10.170.137 colon 8000 ports slash exploit underscore me. Click enter, and it has downloaded this file now. Okay, we don't need this Python server anymore. Go to here, back, open our hello project, import file, and now we have it. Select file to import. Okay, so now what we have to do in Gidra? So examine the binary in Gidra, open the binary in Gidra, analyze it. Let's examine the main function. In the middle left is a window called symbol tree, and there's our main function inside. Symbol tree, functions, and main. So let's go to this and click on analyze. Let it do its work. We see simple symbol tree here, and we are looking at symbol tree, functions, and inside function the main function. Click on here. Okay, do we see main function here? Yes, we see main function here. Click here, and we can see there's a code undefined main int character local 12 10 bytes, SUID bit set is 0, puts type your name, it type your name and gets, it is getting the asking for value. Gets is like it telling us to telling us to type in the value, and then it's printf local 12. So let's see what we can do. Okay, click on OK. Okay, as we can see that Gidra does a pretty good job. Click on OK here as well. Let's run it. Gidra does a pretty good job when compiling small binaries like ours. We can see there's an array of character called local 12 with the size of 10 bytes. And what do we have here? Why is it dangerous? So what is dangerous? The gets function here. What is the get function here, which is getting the value of local 12? It's a dangerous function. Why is it a dangerous function? Because the reason, where is it? Okay, where am I? Huh. And you couldn't use it in a standard program. Why is it dangerous? Because this function doesn't regulate the size of the input. This means that we can provide the input that is 30 bytes long, but our buffer only takes 10. This is why segmentation fault is occurring, and it is the also the reason we can abuse this binary. It has some SUID bit set as well. Okay, so the reason why this slash bin slash sh string and not dash p, which we will need for that, but that's because we aren't specifying the dash p switch. So if you remember, well, we found out the binary has the SQL bit set. Yes, we did, but this that is that in itself wouldn't give us a root shell when running the exploit. That's because we aren't specifying the dash p switch. When passing our slash bin slash sh argument to a system function in the libc, there is only string this and not string dash p. So dash p is the, I guess, using it's something effective. Yes, without the p switch is that the real uid user id of the process is matching the effective user id. If you want to read about more, there is an article here, you can read it from Geeks for Geeks. Anyways, this doesn't matter. We can escalate our privilege with the ret2 libc exploit even without the dash p switch, thanks to the sud function inside of the binary. So let's find the leak function. So we have to go to program trees, exploit me, and this program tree exploit me and got dash p. Click on here, and what do we have here? We have this puts, gets, and suid. Okay, on the left hand side you can see the address next to each function. That address is exactly the one that we will passing to the puts function. Okay, as I said in the previous talk, we can choose any function from puts, prints, and gets. It doesn't matter which function, as long as keep in mind which you have chosen. We will use gets as my leak function. Now, okay, if you are using get as your leak function, then set uid with the next function. You know, let me tell you. On the left, we'll be passing the puts function as an argument. As I said, we can choose any function as long as we keep in mind we use the, if you use the get function, then the next function will be what we will using. Next we will have our argument ready, and the only thing we need to do is pass it the puts function. So now let's pass it the puts function. How do we call puts? In the procedure we can find puts in the procedure linkage table plt and call it from here. Plt is under program trees. Where is program trees? Okay, okay, where am I? Program trees, exploit me. Okay, this upper is and got got, no, dot plt. Where is it? Where is it? It is right here. And we can see what we can see: undefined return. Let's go down. Okay, return, push. Okay, let's go down a bit more, and let's see what we're looking at. The puts function inside the dot plt section looks like this. The puts function. Okay, so we're looking at the puts function, which is inside. Okay, the puts function inside the .pld. Where is the puts function? Where is it? Yes, this is the trunk function puts, and it is the address is here. The main 00400 this. Okay, so let's move on. We have, what is the name of the function that is under gets in dot got? It was suid. Click enter, and now last one is creating the exploit. So I guess we can cancel this terminal here, terminate this machine, and now let's go to the exploit part. We don't need gidra anymore. Don't save it, cancel it out. Okay, I myself also not, I'm also not very comfortable with reverse engineering, but let's try this exploit because it is actually a guided room. It is telling us everything. So let's see, let's create a Python exploit. Let me name it exploit.py, and we will be using vim. Okay, so to enter the insert mode, that is, using vim, it's using I key, and now we are under insert mode. So let's copy the first part, and okay. So if you want to exit out of this insert mode, you have to use the escape key, and so this way you are now, out of this insert mode. You can use colon wq to save and quit vim and click on enter. So this is how you can quit vim now. So let's start our exploit, entering insert mode using I, and what we have here. This user slash bin slash environment is a shebang that makes our script a standalone executable, which means we don't need to run this script with Python 3. On the second, we have from pawn import everything. Is this star sign is actually means everything. We are importing everything from the pawn library into our script. Second part is context binary equals to binary name, elif equals to elif binary, rop equals to rop elif, libc equals to this, and p equals to process. Let's see what we have here. First, we can see that we are assigning the exploit me binary into the binary variable. On the next line, we're creating a variable called elif, so we can manipulate it with our binary elf object inside of this script. Next, we have libc, assigning the full path to the full path of libc to it. And at the last, we're seeing what we are seeing. We're seeing p process. It should have something about p process. The last thing is spawning our binary as a process. You can see we didn't specify which process to spawn. That's because we added our binary into the context. Now we will be creating the rop chain to leak the gets function. So we are leaking the gets function here. Copy this part 3, paste it here. So what we are doing, the basic logic of ROP leak chain is as follows: popping the RDI register forward argument, filling the register with the address of the gets function, okay, executing the puts function with loaded argument. So we are now, after filling this RDI registry with the address of the gets function, we are executing the puts function with argument, returning to the main function with already leaked function, returning to the main program. So let's break it down. This P64 returns the byte string from the data passed in the argument. This returns an array of address in memory where the instruction pop RDI and return occurs. So it returns an array of all the address where this instruction occurs. And since we only needed once, we're specifying this dash O as well, 0 as well. This brackets 0 as well. elif.got.gets returns the address of the gets function, returns the address of the push function from the .plt section. We get the address of gets from got.plt section, and we get from puts address from .plt. elif.simple.main returns the address of the main function. So let's move on to the fourth part. Copy it and paste it here. In this part, we will be using this p dot Refs the line multiple times. With this function we are getting rid of any unnecessary line. We have send line payload, we are sending our payload, created payload, leakage payload. Then we have this u64. We are unpacking the byte string, one just 8 bit 0. What is it? The padding is done by adding additional null bytes. So this is a null byte here. Strip is at the end of our byte string is the new line character slash n, which we want to get rid of. And the strip function does exactly that. Dash p dot rip line is reading the initial byte string. It's just reading. So you're done reading. Let's move on to part 5. Copy this code and see what it does. Okay, in this part we are printing our processed leak address, and then there is a little bit of math involved in calculating the base address. So let me explain it. Imagine our leak as some address that changes every time. Yes, because we know that it is dynamically linked, which means it changes is its address. The only thing we know about it is that this address belongs to the gets function. Okay, we want to calculate the base address of the libc function, which will also be different every time. But now comes the interesting part. The range between the base address and the gets function is always same. So basically their values is changing, but their range between their address is always same. Okay, so since we can treat addresses like numbers, we can subtract the address of gets function from our leak. So this will give us the base address. This gives us the base address of the currently linked libc, and we can print this value out to check if we are done correctly. So let's move on to part 6, which is, I guess this is the padding, and let's see what it does. Okay, we can start by creating another payload, and we can use the variable payload for this. So once again we are starting by assigning the already created padding as the beginning of the payload to cause the buffer overflow. The basic logic of this spawn shell ROP chain. We are popping the register for filling the RDA register with the byte string slash bin slash sh. Return instruction is for stack alignment. Just think of this as something we need to do, otherwise we will occur some problems executing the system function with a loaded argument. Let's break down every function in this part so we can fully understand what's going on. We have already talked about p64 and find gadgets function, so I'll skip this. This libc search runs the iteration for every virtual address that matches the iterator for every virtual address that matches the byte string slash bin slash sh. Next is function returns the next iterator from the founded matches. Lib.symbol.system returns the address of the system function inside of our linked libc. Since our initially defined the libc variable as an elif object and later rebase this libc with the first ROP chain, we can now call the system function right from the libc. So now we can call the system function right from the libc because we have this libc variable as an elif um, elf object and later rebased it. So let's copy this part, last part. Now let's exit out of the insert mode using escape key esc. It will be at the top left corner of your laptop or desktop. So let's use colon wq to save and quit. Click enter. Okay, so let's see, this is our exploit, so make it executable. Chmod plus x exploit dot py. Okay, so now we have to do is simply run the exploit and then we will have root. So let's run this exploit dot py, and it is running. Okay, I guess we are root. Cd into slash root, and let's get out this root.txt. So this is our flag. Copy it from here, and that completes our task 7. And if you got here, you should have a basic understanding of how the ret2libc attack works. I made the exploiting a little bit harder and didn't turn off the ASLR. It's turned on by default on most Linux distribution. Plus, I wanted you to know that it is possible to bypass any of the protections. Okay, so I hope you enjoyed this room and learned something new. So let's click on complete. So now we have completed this Tryhackme room return to libc, and I hope you enjoyed this video, and yes, thank you for watching.